Hey folks, welcome back to another Ruby Rogues. This week on our panel we have Ayush Nuatia.
Hello, hello.
We also have Valentino Stoll.
Hey now.
I'm Charles Max Wood from Top End Devs. And this week we have a special guest, and that's Emil Kampp.
Hey everybody.
So Emil, I'm just going to clear my throat because, wow. Okay, let me try that again. So, Emil, I found you. I've been corresponding with people some on the Discord for Kamal, which is the deployment technology that DHH put out. I think he made kind of a deal about it at Rails World last year, and then a whole bunch of exciting stuff this year with Kamal proxy and stuff like that. I mean, I switched over from Kamal to Kamal 2 with a whole bunch of help from you and others on there. And I have to say, switching over was a little rough. Having switched over, it's a lot nicer. So anyway, so beyond kind of what I know about you from that, what should people know about you?
Well, so I think, first off, I am a mountaineer. And in order to facilitate that, I live in a very flat country. So I do a lot of running, and then I need to pay for my travels. So I do also engineering. And I've made a career of doing sort of critical infrastructure or things that have real world impact and real world consequences if something goes wrong, right? So both in terms of security and robustness and things like that. And that's everything from the fintech or the payment industry to civil engineering to online voting.
Wow. Yeah, it sounds like kind of what our topic is here, which is building critical infrastructure. So you've done some stuff that I kind of need to work, I guess, for lack of a better way of putting it.
I mean, so banking obviously needs to work, right? People get sort of pissed if they don't get their money.
Yeah.
And then for civil engineering, I worked on tools that the engineers would use to build the airplanes, which and run tests on them, right? So both test benches and design benches for airplanes. And I mean, that has a real world consequence because they fall out of the sky, right? If you mess it up.
Yeah, that would be bad.
And then, online voting, that's a whole thing. And you guys in the US just went through one of these messy events, and they're messy everywhere, right?
Oh, yeah.
And recently I moved to compliance and sort of trying to make that easier and a better experience to become compliant and to obtain certifications.
Right. Makes sense. So let's just dive in. I mean, I'm trying to think if I've ever worked on anything that was, kind of at the level of, hey, if this breaks, then, really bad things happen. I mean, if it breaks, I've had them come to me and be upset like really bad thing happened, but right. It doesn't affect society at large. What's the difference between working on those apps and working on just kind of your, you mentioned not e-commerce or not, hey, I've got to manage my social media or, get podcasts out on time.
Yeah. I mean, there's nothing, just to be clear, there's absolutely nothing wrong with that, right? That's just, I started out in that area as many developers do, right? Building like some ad system when I was very young, and then moved to some, sort of offer platform. And then I sort of realized that it was just inconsequential in a way, right? I looked at people, I had people around me. My father is a civil engineer, right? And so I had people in my sort of my family, my near family, that was building things in the real world. And I was like, I want to do that, but I do like this computer stuff. So can we sort of maybe find a way where I can build things in the real world just using my computer? And so I slowly started to shift over into something that was founded more in civil engineering and sort of industry rather than commerce.
Mm.
And then I started in a fintech company where I was part of building out and continuing to build on a system where you can basically it's like direct debit bank transfers but worldwide.
Okay.
So and there it doesn't necessarily mean a lot to you and me. And it's the same with there's a bunch of them now, right? Like these send money home types
Yeah.
things. It doesn't mean a lot to you and me, but it does mean a ton to those who is on the receiving end of that, right?
Right.
Because that's like half a year's pay or something that comes in, right? Um, so it does matter to those people. So yeah, that was sort of where I ended up, and we are moving a lot of money. Like
Hmm.
it seems it's one of those where little like it's a lot of tiny things that add up, right? There's like millions and millions and millions of dollars being moved around for that purpose. And you don't want to mishandle those money, right? So you are hooking into the banking infrastructure, into Swift and into the IBAN network and the whole sort of PC compliance and everything with that, right? So you need to make sure that the software is robust, well tested. Like testing has been a main thing of mine for a long time because of that. Um, and also documented well, right? So that's where I sort of started out with being required to document what I was doing and how it was supposed to work, rather than just shipping fast and breaking things. I was required to test and document, then test, then stage it, then test some more, then ship and not break things. So that was a different paradigm.
Hmm.
Yeah, so that's sort of where I first met that, right? And that was a pretty great experience. So I was like, oh, can I have more of this? Can I maybe even get even closer, right? Yeah, so that's where all that started. And then I was hooked on the whole, can we test it? Can we build something that runs Ruby on Rails but makes a difference to people's lives, like in real world, right?
Yeah.
So this was basically a payment situation just built in Ruby on Rails. And back then, many of the banks didn't have a proper API, so we ended up scraping a lot, and that's, against terms of policy and terms of service and all of that, and they were really mad, and we went through that whole shebang of getting, sort of scolded for that for a while. Yeah, so it was a bit the Wild West back then, but it's definitely gotten better, and I think there's a lot of, again, sort of compliance work and legal work that went into the EU did a lot to make sure that banks would have not standardized APIs, but a minimum level of information that you could retrieve with an API, which made all of that a lot easier, right? It
Hmm.
also means that I can technically build my own banking app for my own bank account because I have API access to it. It may not be obvious, it may be poorly documented, but it is there. So I think that's pretty cool.
Yeah. Um, I'm curious if Valentino or Ayush have experience doing this stuff.
Nothing that critical. No, the closest I kind of came to anywhere near that world was when I worked for TransferWise, but I was an iOS developer, so I didn't really have to do any of the hard stuff. I just made API calls, but I know they were also doing quite a lot of the scraping and stuff. There's a lot of Selenium going on behind the hood to get into different bank accounts. It's yeah, it's all a bit scary when you think about it.
Hmm.
Yeah. Yeah, it really is, because like your whole banking experience is tied up on some scraper working correctly and not messing around with the thousands delimiters, and the cent commas are different on different regions, right? So you don't want to mess around with that. I did transfer some money incorrectly. Luckily, the backbone banking system is pretty robust as well, so we were able to basically not move the money anyways, right? But I did move far too many money the wrong place.
We've all
Whoops.
been there.
Yeah,
I'm rich. Never mind.
that was a back-breaking day.
I'll bet. So I'm a little curious as we get into this. Like you mentioned testing. What does your testing setup look like? Because I mean, I'm sorry, when I write my test, it's like, okay, it's good at, like, I'm reasonably confident, right? But I'm not like ironclad confident, like banking level confident that my code works right.
Yeah, that's a good question. I tend to not be too dogmatic. I know there's a lot of like do this or do that paradigm, or do test first or whatever. I I tend to just play around with it and make myself certain first that this is gonna work, whatever I'm sitting with. Um, and then when I know that it, sort of I can see like, okay, it works, it does what I need it to do, then it is worth testing, right? And then I try and test on the lowest possible level first, which means I will start with something like unit tests. And for that, I want to permute everything, right? You want to make sure that every argument, so you basically start with the least amount of arguments for a method, and then you add in arguments slowly I use aspect, so it's in every context block or in every describe block, right? So you're certain that every version of every argument is tested and has been permuted. Yeah, so that everything, like every variable, has been tested on its own, so you know how it behaves both with and without that particular variable. And you also know how it behaves if the variable has like the wrong type, right? So because Ruby isn't quite where we have type safety yet, there's a lot of work going on with that, but we aren't there yet. So you want to make sure that we can handle strings, numbers, not strings, trues, booleans, whatever. There's like, I have a little thing that basically says, take this and just cycle it through all of the different types it can be, and just put in garbage, so that I know it doesn't break when a number is presented rather than a string or something stupid like that, right? And then you slowly move up. So you're confident that this method works, and then you move up to whoever called it, and then what I do is I go through and test that. But I think opposed to what DHH preaches, or at least sort of, he has this idea that you would go through the entire stack, and I believe that they at their tests do that. I tend to not I tend to sort of stop testing at each level, right? So model tests are their own thing, and then when you test the controller, you basically verify that the model is being called with the expected parameters, because you've already dealt with the parameters on a lower level. So it's not mocking per se, it's just that I only need to test that the model was created or was called. I don't really need to test that it was the correct argument, right? Because I'm certain about the correctness of the arguments on a lower level than that. And then you sort of slowly move up, which means that I find that means that the individual testing levels, it gives you a little bit more freedom to sort of move a model around, because it's coupled somewhat on a test level, but not tremendously, right? I only coupled the controller to the model in the sense that I checked that the model was called, not that it was called with a particular set of arguments. So it makes it a little bit easier to also restructure your tests when your code change. But yeah, it's just a lot of work on lower level things. I'm a big fan of Sorbet, but it's not quite there yet. I think it works reasonably well, but it's very hard for developers to use. So I think we need to do there needs to be a lot of work done in terms of making it nice and sexy to use so that we can get people to use it, right?
I'd love to dig in a little bit more on the testability aspect, because one of the biggest things I see miss is maybe like skipping over like maybe some lower level implementations, and then like a system update breaks something and it just wasn't covered, right? Like, how do you go about like, weighing whether or not that it's worth it to like actually run like a system command or an external API call or something like that?
Yeah. So system commands, I usually check just that the signature of the call is correct, and probably that it returned the right thing, right? So that if I hit the OS, I'm basically testing that I gave it these parameters and I expected something back, like a string or whatever it is, right? Because it's so hard to know what it was supposed to be, because sometimes the system commands will change their signature, but not necessarily the return value, or the return value, but not the signature. So that's very hard. I try to not go there. I try really hard not to go there because it's out of my control, right? On the other end, when I call other APIs, I definitely test that. I use something like VCR or something. I capture all the network traffic, and I make sure to do the same kinds of sort of making sure that if I call it with these arguments that I have control over, I get this particular response. And if I do something else, then it breaks, right? Or it gives me the incorrect response. And I also found that, for example, with banking, that one of the cool things we did was that we basically took all of the historical records, right, that we had for all the bank accounts, and we basically used it as a test bed, because then you can train on that. You can basically say, if I feed it all of this information that we know happened, and it happened correctly because it happened, like a year ago or two or whatever, it should result in a particular set of like, it should result in a particular value on the account, right? So you can actually use historical data as a test bed, and that means that you have a factual way to check if it's correct or not. So yeah, I tend to use that as well. I also use that when I did software for the sort of civil engineering and building flights and testing that, right? We also used a lot of existing information to make sure that we had input output. So we understood that given these inputs, this is the output that we would expect, right? We could basically take old designs and try and run them through, and you can see if does it break it down like you would expect? Does it sort of fit to the engineering design standard that we were implementing against? They also have test value that you can use, right? Or test data. So it's also about going out and finding big test data sets that you can use to also make a statistical sort of approach, right? I'm not making any statistical claims, but I am running a lot of tests on a lot of data that, you can be reasonably certain that that if there were errors in your system, it would have been caught by this, because it's so much effective production data, right?
Yeah, I imagine that working with like the public sector that you would have a lot of access to that data, right? I guess depending where you live.
Yeah, I mean, interestingly enough, none of this is for the public sector, which is a little bit weird. You would think that it was, but it actually isn't. Like, the regulation of the aerospace is public sector, right? But the actual building of airplanes is a private commerce, right? Or private industry. And likewise with banking, the regulation of it is public, but the actual banks are private entities. And likewise
do you find that difficult for like the data access? Like, is that data proprietary then for like doing large swaths of tests or finding it?
Yes, but most of the times the companies are interested in providing it, right? Like if you go out to big airplane or aerospace company and you need to design a test system for them or something to help them build, right? They are interested in giving you that kinds of data. So it wasn't that it was hard, it's just that it is also quite narrow in scope. Like it's more or less only for that one, right? So in banking it would be a lot of records, but only for one bank. So you would only know how it looked in one type of account system, right? And then you would run all your tests on that. And now, 2 seconds. Yeah. There we go. Hello.
Hi.
So it's not that it's hard to get, it's that it's quite narrow in terms of sort of like what, it doesn't have a lot of breadth. You get it for like one bank or one airplane company, or you get it for one company who runs elections, right? Public elections is a bit different. By definition, you don't have any test data because all of the records are sort of, you don't know who voted, so you can't know how to test that, right? So you have to do a different testing paradigm there.
Yeah, that makes sense. I mean, here in the U.S., we have a anonymous ballot as well, right?
Yeah.
And I don't know how they do it in other states. I mean, I'm involved in the process here in Utah, and yeah, you send in your envelope, and they with your ballot in it, and they validate that your signature matches and stuff off the envelope. But then they pull your ballot out of the envelope and put it in the pile to be counted. And right, they don't track who you voted for in that case, or at least they're not supposed to. Right.
Correct, and that is also the case for the digital solutions.
Right.
A colleague of mine, Stefan, who is a cryptographer, a previous colleague of mine, he did a lot of work of sort of gathering together a lot of the academic work so that we could exactly do that in a cryptographically safe way, but online.
Mm-hmm.
And you could also do it in a way that it was, you could track it and you could ensure that this was in fact the case. Like you could give the log data and the trace data to mathematicians, and they could verify that mathematically it could only ever have worked if these rules were followed. Which was like, you anonymized and you did mixing and you did a lot of these things, right?
Right. So you protect the identity of the voter, but you also ensure that only people who are legally permitted to vote, and that they only cast one ballot and things like that.
Yeah, exactly. And the test, sort of the build idea for that and the testing regime for that is significantly different, right? Because this is in fact the public space. To your point earlier, Valentino, this is a public domain, right? So you are a bit more scrutinized. You're also publicly scrutinized by everybody, right? Because we all know how it went with the Dominion voting machine case, right? That went real fast, real downhill. So, yeah.
Well, and you bring up the Dominion voting machine case, and whether you believe that they worked or didn't, if there's enough population that doesn't trust it, then it causes problems, right?
Yeah. And that's the same everywhere, right? And I found that sort of on a completely different but somehow related topic. I really found that the aerospace or the airplane industry was really good, because the what's the American one? The TSB, Transportation
TSA.
Safety Board. Is that TSA?
NTSB.
No,
NTSB.
TSB, right? Yeah, those are the ones that do crash audit, that sort of like go through.
Oh
and,
yeah, the NTSB. Yeah.
Both them and the European counterparts have a really, really cool way of going about it. They don't ever go and say, "Oh, it was that person's fault," right?
Mhm.
If the person hadn't slept enough, if the person couldn't read the dials, it is the fault of the plan that made him not have enough hours to sleep, and it is the fault of the dial for not being visible enough, right? So it's not, they don't ever cast personal blame, or they very rarely cast personal blame. And I really thought that was a super cool way of going about it. Also, just from a sort of like evaluating if something works well, right? Just like from a human perspective, and when you do leadership in tech, or if you guide or lead others, that I found that really valuable, sort of that whole way of thinking about it. And they collect a ton of evidence, right? They have a very structured way of collecting that before they then conclude that it works or didn't work, or that this was the fault or that was the fault. But they also, I think I learned a lot also in terms of like having redundancies. Like, what happens if this thing breaks? What happens if your job runner doesn't run? How are you alerted? What happens if your email doesn't send? How are you alerted? How do you have alternative options? Do you have an alternative email provider that you can switch to easily? Do you have alternate job runners that you can switch to easily? Do you have any of this, right? So that redundancy ideology was pretty cool. And for like large scale systems, it pays off to have extras of these, even though, you use somebody like SendGrid, or use somebody like MailChimp or something, and they say that they scale, and they do, right? But then ever so often it's down, and it's pretty nice to have a backup, even if it's a tiny backup, and even if it's just a up and coming fairly cheap one. It will do the job for like a day, right? And you will actually still send stuff out, or you will still process jobs, or you will still whatever it is, right? Also running like on the big scale, running something like multi-cloud, or running something like an open stack where you can actually move to somewhere else pretty fast. There was that case, was that the Australian case where the bank got taken down because someone at Google decided to delete their account, right, for like 160 million US worth of servers. Just got nuked. So for those cases, it's pretty nice to have a second provider backup and some way of getting there, right? That is more a DevOps problem. It's not really a problem that I've ever solved. It's a problem that I have, sort of like assisted with and talked about and verbalized a lot in companies. But it is to a high degree a DevOps solution that needs to go in there, and not one that I am gonna build.
So you're talking a lot about like people's lives and their livelihood, their money, like things that sustain life, right? And so like obviously these infrastructures are critical, like what tools you're using are critical. So I'm curious, like what about like Ruby and Rails, specifically feature wise? Like, do you see as being like, oh, well, this is like part of that critical process?
I think the main part for me is that it can be built. You can write it so that it is absolutely readable and understandable what's going on. So you can reason about the what's going to happen, even without necessarily understanding the language fully, or even without understanding what this active record method is going to do underneath, because stuff is named well and because it's ordered and organized well. You can reason about what's gonna happen, and you can have an expectation, and it makes it a lot easier to build complicated things. Like, you can go and test it afterwards, right? But just getting something that's complicated up, like just getting it up on its legs, it's really nice to have something that is structured well, and that you can reason about, and that you can talk about sort of what's the consequence of this method or that method, right? Come right up to my hand. Yeah. There we go.
Special guest co-host.
Yeah, exactly. But I think, and also I find that I've done a few frameworks throughout my career, right? I've always come back to Rails and Ruby, and I also started there, so maybe I'm biased, but I haven't found any of the other frameworks that provides the same sort of consistent experience through every part of the application, whether or not you're doing low-level active record stuff or you're doing high-level system tests or whatever you're doing. It's consistently the same experience everywhere, which means that it's fairly easy for a developer to switch gears and do something else, right? In the stack, I mean. So like, you can have a person who's sitting and doing the Swift transfer 1 week, right? And then he can go and he can look at the web scraper the next, because it's consistently the same experience. And you can write it in a way, if you have a good style guide and you have good code review, you can get it to a point where it's the same experience every time. And you can get abstraction levels and abstraction layers that feels the same. And that makes it easy to build something where you can also easily plug out something and put something else in, right? Like, you can switch out one database provider for the other without much problem, right? Or you can do whatever it is that you feel like you need to change can be quite easy and quite straightforward if you've set it up to be. I'm not necessarily talking about modularity in the Sidewerk level of aggressiveness that Shopify has, right? But you can definitely do something along those lines with just talking about it, organizing the code well, and just sort of thinking about how is this going to be tested. I find that that's also part of it, right? It's like, how are we going to test this? Because if we're going to test it in this particular way or that particular way, then that informs the API and the sort of the interface for it. And a database, you tend to test the same way. If it's file uploading or downloading, you tend to test that the same way, which makes it easy to switch out one component for the other if your test paradigm is the same, right, for that component. So I feel that's some of the reasons that I've chosen this again and again, right? And also, like DHH said on his keynote, this is it can be a one-man army, right? You can be pretty fast and pretty dangerous with it, which means you actually need fairly low headcount to get somewhere really fast. And you can actually get something that's really secure, solid, safe, robust, and easy on the eyes and nice to use with only a handful of people, right? You can get somewhere with just one person, but you can definitely get a long way with a handful of people.
You are so speaking my language, man. This is why I'm here.
Yeah.
So one thing that I'm wondering about with all of this is, it sounds like depending on what the concerns are in the app, right? So whether it's banking or voting or, right, you may have different concerns about uptime or stability or, resumability, if Google deletes all 1,800 of your servers or, whatever, right? So how do you begin to start looking at your application and saying, well, for example, in banking, right, we have to make sure that we don't have any of these kinds of issues, bugs show up, right? Make sure our accounting is super robust. But then you're talking about the voting, and it's, hey, we've got to protect user data and make sure that, right? So the areas of concern are different. So how do you start to address that? And then from there, where do you start to dive in and make sure that you've got a sound strategy for making sure that you're meeting those requirements?
Yeah, that's a good question. So let's just take voting because it's up and hot and a topic these days, right? So let's just start there.
Always.
So one of the things there is that you definitely want, so like user privacy, there's a few, right? There's like the whole user privacy, and then there's the vote secrecy, and then there is the use it needs to be receipt free, and like there's a bunch of these academic properties of a vote and an election, right? And you go through each of those, and you just sort of sit down and you start at one, and then you try and figure out how to do that, right? This is really the job of the cryptographer. Like, how do we get this organized so that we match all of these? And then once we have a viable protocol that will do this, then the developers come in and we look at the protocol and we go like, okay, this thing is about encrypting the vote. That needs to happen as early as we can possibly get it to happen, which means it needs to happen in the voter's device, right? So we need to generate, we need to pick a curve, a cryptography curve, and then we need to basically generate key pairs in the device, and we need to encrypt it as early as possible, right? And so you go through sort of like rigorously and slowly and just sort of reason about when will this part of the process happen and where does it need to happen, sort of more on a timeline. Then we need to transmit the vote. We transmit the vote to the server, and then the server needs to basically allow, if you need to allow tracking, or if you need to allow receipts, or whatever is the property you need to have, then you need to figure out a way to provide that at this point. And then you go on to something like anonymization, which is effectively where you take one envelope out of the other envelope, right? To do the analogy. That needs to happen in a way that you can prove that it happened. So you need to have a good trace here. You need to have good logs and traces that you can publicly show. And then, so you sort of move through the chain, sort of like the event of a thing, right? It's the same. And so you sort of need to reason about where is it going to happen. That gives you some ideas of do we need a web app? Do we need a mobile device, mobile app? Do we need to run cryptography? Do we need to run something advanced on the user's device, or is the user's device just a portal? And that gives you sort of ideas on, or some insight into how this should be organized, how this should be tested, how this should be planned out, right? But most importantly for voting is basically making sure that everything is tracked. And we grabbed part of the concept of blockchain, which is hash chain, right? To basically hash everything together so that you can't move stuff in the middle without everybody being able to know, right? Things like that. Hvad så? Jeg skal.
Jeg er snacksulten.
Ja, du må godt gå op i skabet og tage noget snack. Jeg kan ikke gøre det nu.
Hvad må jeg tage?
Det du har lyst til.
Så vil jeg tage slik.
Det må du gerne.
Det er simpelthen det torsdag.
Ja, det er i orden. Det må du gerne.
Wow.
And for like for banking, right, you wanna make sure that the point is to get money from A to B. So you want to reason about, well, first off, how am I gonna get the number that they intend to send, right? Like, where does that come from? Where does the sort of outgoing amount of money come from?
You know,
This is the second one.
How many do you have?
It's hard to be home alone with kids. But so you want to basically say, okay, so where does the money come from? And then you want to reason about, well, how can I prove that the money that came from there, that I got it right? Like, how can I make sure that the intent was to send it to me? How can I make sure that the amount was correct, right? Because like we talked about earlier with TransferWise, for example, there is a lot of web scraping. There is a lot of this sort of craziness going around. Less so now, more so then, right? And you want to make sure that you have either done it a few times, that you're quite confident that you've run it on big data sets. Like, you need to be certain that you can pass these things correctly. And then you want to sort of grab that information, and then we get into the whole banking of how do you then move them. There's like Swift, and that's pretty taken care of. The only problem here was that it was slow, right? So what we would do is that we would basically assume that if we could read the intended money here, we could effectively pay it out here immediately, and then just do the in-between transfer later. So we would basically have big stacks of money around the world, and we could immediately pay out locally, or take money in locally, and then we would transfer later. So in that case, it was more a question of, can you verify the amount here, and can you verify that it's the sort of the correct amount and the correct intended amount, and can you then make that payout over here? Yeah, that's good.
kan ikke åbne låget på slikkassen.
So come on, man. So then, can you do the payout here? Is there sufficient funds? And then after that, you sort of say, okay, now we've effectively solved the user journey, right? We've taken money in, we've paid money out. Where effectively the user is happy, or both users are happy, right? Nobody knows that we didn't actually move the money. And then we can take it slow, just do it properly, make sure that we interact with the Swift network. That's a bit slower. So you need to have a buffer in both ends to do it, right? And the
Hvilke sprog snakker du?
English. And the important part here is the ability to scrape, right? So one of the critical points here was that you have to be able to always scrape these websites in some capacity, and you have to actually write your code. Back then it was scraping. You have to write it quite robustly and sort of reason about what happens if the layout changes, because banks change their layout surprisingly more than you would think. Because they don't care about your ability to scrape it. That's not their business, right? Which is fair. It just means that you have to think about the robustness of a scraper like that, because what happens if the item is not classified the same, if the DOM element doesn't have the same class or the same ID as it used to have? Can we find it by reasoning with words? Like, can we figure out, well, if it's like, if it says some, can we maybe then figure out what's over here next to it, because that might be the number I'm looking for, right? So there's sort of like reasoning like that goes on. And then there's accounting, like a lot of accounting, a lot of keeping tracks just for legal and compliance reasons on where is the money going, who's it going to, KYC, all of these. There's a bunch of tooling after that, right? Which is sort of where I was introduced to this whole compliance thing. Like, how do you make sure that the people you're operating with are in fact the people that they say they are, and are in fact the right people that you're supposed to be operating with, right? So that was also a journey. Like, how do you even know that? How do you make tooling for them to identify themselves at the latest possible time, so it's the least amount of sort of burden or the least amount of friction, and make it as easy as possible, right? There's a bunch of providers out there that can help you do that. You can also do it yourself. It's not super complicated, but you are now dealing with people's private information, because now you maybe have a copy of their passport. How do you deal with a copy of a passport? You have to sort of be like, okay, where do I store this? How do I make sure that it's encrypted? How do I make sure that none of the developers can access this, right? Because you don't want developers to just SSH onto the box and just be like, oh, let me just download all the attachments. So you need to make reasons, sort of need to think about how do you then protect this data from yourself in some way, right? So that it goes deep and it goes far, right? You can talk about this for a long time, and about all the reasonings you have to make, but at some point you also have to protect your systems from other developers, from other also high-level people in the organization needs to be kept out, because the higher up you are, the more spear phishing you are, or whaling you are effectively the subject of, and the greater the risk, right? So you want people to not have access. Maybe you even want the CTO to not have access. Like there's a bunch of considerations like this. In the banking one, I was a senior developer. I had access. Then we had one of the compliance officers. She had access to the Swift network, and then but the CTO and the head of sort of the COO type person didn't, right? It's because it posed too much of a risk. So there's also like these human factors you have to think about when you reason about the security of a system that actually impacts and has something to do for real world people. That was a very long spiel. Sorry.
Yeah, it's fascinating when there's so much on the line. Like most of the apps I've worked on, like if it went down, it's like, yeah, fine, okay, it's not ideal, but it's not the end of the world. I kind of want to pick up on something you mentioned quite a while ago, actually, on about type checking and sorbet and stuff like that. Like, I'm very much a fan of the dynamic typing. I do have a background in static programming, like because I started as a mobile developer, so I spent a lot of time with Objective C, with Java, and with Swift. So I do have that background, but ever since I kind of switched to Ruby, I just love that dynamic style, and I just find it easier to work with. But I also get that when it's critical infrastructure, the type checking is just almost essential. So I'm curious about why you went with Ruby and Rails when the infrastructure is so critical and type checking is clearly something that's important to you, and it's kind of bolted onto the language. So what motivated you to go with Ruby and Rails instead of something that has it natively?
Yeah. So it is to a high degree about the speed and the very well built testing frameworks that is around it, right? So even if it's not statically typed, you can test a lot of things and you can test it in a lot of ways. Typing is just, or types is just one way of ensuring that the data is correct. That doesn't necessarily guarantee that the actual data you are trying to read in is of the correct format or whatever. It just means that once you read it in, it will fail because it's not the right type. So it depends a little on what you're trying to do. You can also, because it's dynamic, you can then sort of do things like, okay, you told me it was a CSV, and it's obviously not a CSV. And it obviously doesn't have a string where you told me a string was supposed to be. But I can see how this can look like a string. Maybe I can just make it into a string for you and move on, right? Like you have these options of making things go a little bit faster and a little bit smoother, because you can sort of just fiddle a little around with it. What tends to happen in these systems as they grow older and as they mature is that parts of the core of the system gets replaced with something like Java or Rust or something like that. So that once you have a really solid part, let's say the transfer engine, right, that transfers from one account to the other, that hooks onto the Swift network. Maybe you want to move that into Java or something that's more static, more slow, but more type robust and more maybe even performance optimized for IO or whatever it is that you need, right? But then what tends to happen is that you still want the speed and ease of using Ruby on Rails and having only a few developers do a lot of features so you can figure out what's good or bad or what works or doesn't, or do a lot of development around trying out this new standard to verify with the engineers that it will in fact test correctly with this airplane, or sort of having that capability to do feature spikes and to do tests or like mini projects. It seems to me that is to some degree lost when you use a more some other language, right? But you are right. Like once you have it down, once you have it locked in, once you don't have any changes there, what tends to happen is it gets replaced with something that's faster or better suited for the purpose. Yeah, I've seen that happen. So the reasoning is that you can go really fast with quite few people, and you can actually get something that's meaningful, that will affect people's lives, that will better somebody's life. You can get it done pretty quickly, right? Like you can get a design system to basically do design. We're not talking like 3D sketches of airplanes. That's not necessarily how you design all of it. That's just the building of it. But you also need to reason about the logic of who does what are the processes, and you can get something like that built in 7-8 months, right? That's, as far as I know, that's and what I could see in the market, right? And what happened was that we basically went a lot faster than everybody else, right? With the same amount of errors. Like it seemed that there was no real drawback to using Ruby in that case, right? And so it was a pure benefit to use the language and the framework.
Nice. Yeah, there's really nothing that can compare to the speed of development of Rails. It's I think we kind of take it for advantage, like for granted rather, as Rails developers. It's when you go and look at the outside world is when you realize, bloody hell, this is a good tool.
Yeah, it is quite insane.
Mm-hmm.
Like I had a colleague who did sort of an AI-based feature spike, like, can we just time box this to like 3 days? And in 3 days, we had a tool that seems to be working, did integrate with AI, had UI, had tests, were behind a feature flag, and was effectively shippable, right? It was not, it was not the best or the most robust or whatever, but like in 3 days, a single person made a full feature spike that could technically be deployed and could work, right? That's pretty amazing.
I'm curious real quick, like I'm in my experience working with like critical systems like this, like once it's built, there's like it's hard to change, right? Like, and mostly because like too the requirements probably don't change very frequently either. But like how do you like approach in those cases like that change? Like is it like build something new and cut one off and switch to the other, or like what are like what kind of systematic approach do you take to that?
I think so. For me, it's certainly about you have to reason about the protocol and the process somewhere other than the application. So you have to diagram it or put it into dance or whatever you like to do, but we need to have a different place to talk about it than in code, because we need to reason about when somebody has a change, we need to be able to reason about it before we spend time in code, and we need to figure out if the sort of the signature of that particular change. Let's say you want to change one hashing algorithm with another hashing algorithm, right? You need to be able to reason if that will break the system just in principle before you start to even try and implement it, right? So I find that it really benefits to have it in a big diagram or have it written out in long form in a document, or like somewhere that you can reason with people who aren't developers on whether or not it will work or not before you even try to implement. Because if you can reason that it will in fact work, it will plug in, it will replace, if you can reason about that before you actually see the code, when you come to the developers, it's a much smoother experience to say, okay, I need this piece replaced with that piece. And yes, the hashing algorithm is not the same, but it is whatever based on the same something, so it will plug in, right? And then we can either have both. If they plug well, we can replace one with the other and you can also, then you need to migrate the data, right? But now that you're migrating the data, it's really nice to also have that conversation with beforehand and with others who are not developers. Well, we have existing data and you want me to plug this thing into this place in this big diagram. What happens to all the old data that went through that point beforehand? Like, what do we feel we need to do about that? Do we want to revision it and say that version less than something can never be opened again or can never be edited again, but can only be viewed? Like, what's our reasoning on that, right? So having somewhere else to talk about it than in code really helps to figure out if you should replace, plug in, or make it as a different service that you call sometimes, whatever it is. I find that having something other than code really helps. Hvis det er meget lavt. Sådan der, sådan. So it really needs somewhere else to have that conversation, right?
Yeah, it makes me think about the old days of Yahoo pipes, like where you could visualize and like in real time update the data flow of any particular aggregate thing you were trying to collect. Are there any tools like that you use to like maybe automate this process, or is it just a matter of getting it documented?
Oh, that's I mean, I've tried a bunch of them. I haven't found one that I really like. I haven't found one that really does it for me. I tend to try and make them diagrams as code, because then they can at least get checked into Git and we can have version control on top of it. But I haven't really found anything that really does it for me. I tend to either do Whimsical or Draw.io or something like that. And then it is just a lot of work to keep it maintained, and that sucks a bit, but it's hard to do without, right? Without somewhere else to reason. And especially when you need to talk to, because it's not only a technical problem, right? It is also a business problem, and it is a regulatory problem. If I'm going to change this piece of the testing bed for an airplane, or this piece of code for the design software for an airplane, I need to be able to have a conversation with somebody who's not a software engineer about the consequences of that, right? Because I need to talk to the civil engineer, I need to talk to the test manager, and I need to talk to a lot of people about the consequence of doing it and the way to do it. And are there any consequences outside of my system that we need to have a conversation about? So it is just sort of like trying to get as many people joining that conversation as possible. And for that, it seems to work better if it's not quite code, because then more people can participate in that conversation, right?
Yeah, I think that makes a lot of sense. I'm still personally trying to find the silver bullet, and the closest I've gotten is Mermaid.
Yeah. And that also works quite well, actually. It's just it works pretty. it works pretty reasonable, and it is definitely diagram as text, right? So I've also used that a ton, and it's decent enough. I find that it has some problems when you get up to really large size stuff. Like it's hard to get enough in there and still have it be viewable and understandable as a human. But I mean, a lot of like building these systems and a lot of participating in building them is surprisingly not about code. It's about talking to a bunch of people who have nothing to do with software development and figuring out if you're going to break their lives, right? Like, are you going to break something completely insane that you had no idea that you were ever going to touch? Because, you know, in the case of this, well, I'm going to change this thing in my my design software. And then suddenly somebody in a factory somewhere is totally confused about how to build an airplane because I did something that, you know, so it's really not that much of a software challenge. I mean, it is, but it is to a high degree a communication challenge, and sort of like, how do we even communicate what this software does to people so that they can use it and so we can reason about the safety of it together, right?
Yeah, it makes sense in the, I mean, I've worked on things at this level of complexity that you have to get right. So, I worked at Morgan Stanley, and I mean, we weren't doing like banking level stuff, but we were doing like investment level and business information stuff, right? And so, yeah, the world didn't end if we got it wrong, but we kind of needed it to get right. And a lot of it was just a matter of, like you said, making sure that all the people who understand all of the concerns and all the things that it touch are able to weigh in and be part of the conversation. And that way, yeah, you don't do things without understanding the implications of how it's going to ripple. I'm working a contract now, and you know, I'm still trying to figure out the ins and outs of the system. And they're managing funds and stuff like that, right? And so, yeah, I'm definitely feeling it here where I don't want to make any changes that ripple through the system. And right. And so this is where when you're talking about like testing and documentation and things like that, where the documentation really isn't around, and there are a lot of other things, I wind up having to ask a lot of questions, and I'm still not sure that all of my assumptions are correct. So yeah, a lot of this really helps in the sense of, oh, okay, if we're gonna nail down robust, you know, reliable things, then yeah, you know, all of these things are important. And I think part of my issue with some of it is just that I like to just get in and solve problems, right? I'm my mentality. I was talking to some other friends the other day, and my mentality is go 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 go. And so yeah, having to slow down and, you know, I joke and say I dot all my T's and cross all my I's. It's you know, it's not my natural state. And I think a lot of developers, yeah, they just want to write great code that solves problems. And so the meetings are tedious, the conversations are boring, you know, and you know, why can't I just go in and just make it work? And the reality is, you know, yeah, what we're talking about here. And so I think it's not just we have these specific concerns, whether they're regulatory or something else. I think it's also that there's enough complexity to it to where you really do have to get in and understand the nuance of what you're doing.
Yeah, and I think also the breadth of what you're doing, right? Like, I know this for myself, right? When I was younger and started developing code, right? It was like, well, there's only one truth, right? Like, either it's 1 + 1 is 2 or it's wrong, right? But that's just not the case when you have these really big connected systems, right? Where, like, well, what happens if I change this protocol? Well, now it's right because it's a different protocol, but now it's wrong because it's a different protocol. So it can be both at the same time, right? Because now, you know, all the other people who used it for one protocol can't use the other, and like it just gets really messy. I think at some point I realized that I liked doing documentation, and that really helped to sort of make me be confident that this could be somewhere you can do a career. Like you can do a career in something that's not obviously developer-ish territory, right? Like because I actually enjoyed doing like architecture diagrams and reasoning outside of the code, and all of these things I found was pretty interesting, and that makes it easier to be me, right? Like it's more fun to have that conversation with everybody to figure out, well, if we do this thing over there in wherever we are operating in Australia, that's fine. But now we've done this change. So what happens to our operations in Austria? Like, is that the same tax system? Can we do both? Like, it can become really complicated when you're operating under multiple jurisdictions and multiple governances, right? Then that can become complicated as well. And you're doing currency conversions, or you're doing unit conversions, or you're doing all of these things. Like, it's so hard that I know that even the space agencies are getting it wrong, and sometimes their stuff just won't work when you get it into space, right? Because somebody converted inches to centimeters, right? So it is just, and that should, like, if you go to a fresh out of college developer and says to him that I need a unit conversion system, or unit conversion method that can go from inches to centimeters, that's pretty straightforward. That's a pretty straightforward ask, right? And you can do that method pretty quickly. It's not really super hard. What is really super hard is getting people to use it, right? So you need to build a unit conversion method that is easy to use, fun to use, at hand when you need to use it, so that you will in fact use it, because otherwise you're going to do it in your head, and then it doesn't really matter that you build a piece of software, right? So like there's a lot of other components to this than just the software. Like there's a lot of things, like there's a lot of backup, a lot of everything, but it is also about making sure that the people who use it correctly. And the way to do that, like we talked about before, like with the TSB and everything, it's not to blame the person for not using the thing. It's to blame the thing for not being available when it was needed, right?
Mm-hmm.
So you need to be like, if I have a unit conversion thing and it's hidden behind, a multiple 3-dot options that you need to figure out 5 levels in, that's the wrong place to have it then, right? You don't blame the person for not using it. You blame the system for not putting it in his face when he needed to convert the measurement.
Yep. I like that. Just from the standpoint of, I mean, I guess where my brain goes is everybody has the responsibility to understand the system and how it works, right? And so everybody has the responsibility then to be aware that this method exists. But at the same time, if I create it, then it's also my responsibility to make sure everybody knows it's there and knows how to use it. And I also agree, though, that if you make it easy or natural to do the right thing, then people will generally do the right thing.
Yeah.
And so, I think I agree with you, but I don't want to absolve anybody of the responsibility of learning to do the right thing either.
No. I mean, that's not what it. I mean, you can absolutely end up being blamed for crashing a plane. Like it's not entirely out of the realms of like the pilot can be blamed, right? But it is also about looking at, did we actually provide the correct tooling at the correct time with the correct intensity and all of this, right? And it's the same here. Like, well, the system didn't work. Well, did we provide enough? Did we scale enough? Did we have enough compute resources? Did we have enough database storage? Was it just so slow that people couldn't use it and it crashed and somebody couldn't get their vote in? Because if somebody couldn't get their vote in, then we get into the territory of, oh, somebody prevented me from voting situation, right? Mm-hmm. So they could have done it again. Like they could have just waited 5 minutes till the peak was down and voted again. But that's like, it's also not really their fault, right?
Right.
So there's a lot of sort of like ancillary non-developer stuff to talk about when designing. I'm pretty sure there is on all systems, right? But the fun thing here is just that this happens to include other engineers, which is very fun. And it happens to include things like cryptographers and people who actually like politicians or whatever it is. It's just, I like the types of people that I get to talk and interact with, right? In this, rather than I get to talk less with marketing and social media and more with like people who build spaceships and airplanes. And I find that's basically what drew me here, right? Is this idea that I get to talk to other people who also have this engineering spirit and this idea to build something in the same mindset that I do.
Awesome. All right. Well, I think we're going to go to picks because we've been talking for an hour and 15 minutes. This is cool though. If people want to connect with you, or if they have questions about what you're doing, maybe you want to pick your brain about some of this stuff.
Yeah.
How do they find you on the internet?
I think go to LinkedIn. That's I've more or less tried to absolve myself of all social media. So LinkedIn is probably your best bet. It's my name. It's right there on the screeny thing. There it is. And then also go on Discord. You can ping me there, PM me, like you did. I'm both on the Kamal, the Rails, and the Ruby servers, so you can just go find me there. It's EKAMPP, so just my initial letter and my last name.
Nice. I didn't know that there were Ruby and Rails Discords. I'll have to go find those.
I can send you invite links.
That would be perfect.
Cool.
All right.
There's one for like Rails development. That's the Rails one. And then there's one for Ruby, which is more like application support and like, oh, I don't understand what this method does, or I need to change this. Whereas the Rails one is more for like, I need approvals or reviews of PRs for the actual core, right? So that's more about supporting of that. So it's less interesting if you're trying to solve a business problem, but it is kind of cool if you want to just peek at what the others are doing.
Nice. Okay. Well, let's go ahead and do some picks. Valentino, do you want to start us with picks?
Sure. I've got nothing but AI picks today. There's been a lot of activity in the Ruby world. Andrew Kane has released yet another AI gem. Bless his heart. It's called Informers, and it basically lets you run inference in Ruby on Onyx models. So lots of Hugging Face models are Onyx supported, and you can now just run inference with those. And he also has Transformers RB if you are interested in running inference on non-Onyx models. So now we have like a complete picture. Hopefully those there are some missing pieces still for larger models, but it has a ton of pipelines already built in. So I would suggest checking that out. The next pick, somebody built this awesome chat app where they've aggregated all of the Rails and Ruby like articles and blogs and guides and everything like that. So you can basically rag the entire Rails community ecosystem in a chat GPT style interface. And it's remarkable. And it does like citations and everything like that. So you can see the original article that referenced whatever it was you're interested in. It's really awesome. It's called Ship on Rails. And it's built with this really cool tool called Nausea, which provides basically like a Rails app ready to go so that you can ingest your own documents to rag against and do a very similar thing. And it's really cool. So I'd recommend checking all those out.
Nice. How about you, Ayush?
Not sure what to take for picks this week. I haven't really thought of anything. It's a cheap one, but I'm gonna go with Blue Sky because I'm quite enjoying Blue Sky in the last week. As I finally signed up for it, and a lot of Ruby folks have signed up recently. It's quite a lot of activity on there. I'm quite enjoying it as a social network. Hopefully, it can stay the way it is. So I'm active on both Blue Sky and Mastodon for now, but yeah, we'll see what happens because Blue Sky is still a VC funded, privately held company. So we'll have to see how long things remain good. But for now, I'm quite happy with it. What else can I pick? I haven't really watched anything or anything new recently because I think I had picked a TV show called Shrinking, which I did the last time, so I don't want to pick that again. I'll go with the music pick because I always go with the music pick when I'm struggling. What's in front of me? The new Tears for Fears album. Check this one out. It's really good. It's a live album with a few new songs from 80s pop band Tears for Fears. So yeah, I think I'll go with those.
Awesome. I've had a number of people tell me I need to join Blue Sky, so anyway, let's see. I'm going to throw in some picks. So I played a new game. I actually played a couple of new games this week. Because the game convention that I usually teach games at is going to be on Saturday, and so I need to be able to teach these games. So I'm going to pick one of those. It's called MLEM, MLEM. And essentially what it is it's, how do you describe it? It's cat astronauts. And the way that it works, it's a relatively simple game. It was almost too simple for me, to be honest. But if you're kind of a casual board gamer, right, it's definitely approachable. So let me pull it up on Board Game Geek. But yeah, so the way that it works is you have astronaut cats that are going into space, and they're basically occupying planets and moons. And so you pick one of your cats, and you put it on the rocket, and somebody's the captain, and they roll the dice. And if the dice match what's on the space on the board that you're on, then you can choose which dice to use in order to move up the board, right? And so if you have boosters move you up for free. The other ones, you have to give up the dice in order to move. And so if you ever get to the point where you roll the dice and you can't use any of the numbers, then you use the ship. And at any point, people can get off the ships onto moons or planets, and you get points for having the most cats on planets. You get points for every moon you occupy. If you go all the way to deep space, then you get bonuses for that. And then the different cats have different abilities, right? So one of the cats lets you start further up the board. One of the cats lets you get off the ship after it crashes, right? So you can go to the planet it's next to or whatever when it crashes. One of them gives you a bonus, doubles your points for the planet it's on. One of them doubles the points for the moon it's on. Anyway, you get the idea. One of them doubles the points if you're in deep space, but deep space is hard. I've played it once, and we never made it to deep space. We got close a couple times, but then I was talking to some other people who had played it a couple of other times, and one of the times they played, they made it to deep space like 3 or 4 times. So anyway, so if you're the captain, you're rolling, and then you just rotate who the captain is. If the captain gets off the ship, then the next person in line just finishes out that round. Anyway, that's basically the game. Board Game Geek has it at a 1.68 weight. It says ages 8+. And yeah, I have an 8-year-old. She could definitely play it. It says 30 to 60 minutes. That's probably about accurate. Plays 2 to 5 players. I played it with 4 players, and that felt pretty good. So it's MLEM, MLEM Space Agency. And yeah, anyway, check it out. And then here, I'll just put a link in the comments here. And then let's see. I'm not sure if I really have any other picks. I know I've kind of been doing other things and getting involved in other things, but I guess the big thing that I went through this lately is I went up to a retreat up in Sundance, which is actually like 45 minutes from here. If you've heard of the Sundance Film Festival, they do actually do that in Park City, not in Sundance. But from here, it's about 2/3 of the way to Park City. And anyway, it's up Provo Canyon, and these guys were running essentially a mastermind for 3 days for Christian entrepreneurs. And so we did a lot of faith-based stuff. We did a lot of business-based stuff. And it was amazing because they just kind of helped me get clarity on what I want to do and who I want to be and what kind of difference I want to make. So just keep an eye out because I have stuff in the works. But it was terrific. And I really want to just put forward, I guess, that just connecting with other people who are doing what you're doing or who are learning what you're learning or who are maybe a little ahead of you on the path you want to go down. It's so helpful. So helpful. You know, kind of like what we were talking about with like the Discord servers, right? So much helpful stuff there. So anyway, those are my picks. Emil, what are your picks?
So recently, I'm gonna pick a book. I recently read a book called "How Big Things Get Done," and it's by a Danish guy called Bent Flubier. So what he did was that he went. I don't know if you guys know it, but he went through statistical data on overruns on big projects, like how far behind is an IT project in general? How much of an overrun on cost do you get? How much of an overrun on time do you get? And he goes through sort of like these different industries and different factors that play into why big things fail and why some big things gets done, right? Like, what are the ways to make sure that big things gets done and what are the pitfalls and everything? And he goes through everything from the Sydney Opera House to like big government IT projects that fail. It's just super cool because it's very sort of data driven, and he has spent his career collecting data on why big projects fail, why all kinds of projects fail. So it's a really interesting sort of window into do this if you really want to mess it up. So by inversion, if you don't want to mess it up, don't do all of this. Do the other thing, right? So that's kind of an interesting statistics to have. So yeah, how big things gets done. I found that was really cool.
Awesome. All right. Well, thanks for coming, Emil. We're going to go ahead and wrap it here.
Yep. Thank you for having me. It was a pleasure.
And until next time, max out.